Good day everyone! Today, we are going to report the Unit 1 Lesson 2, Theory into Practice, Foundations for Transformative Technology Integration. Two perspectives on instruction. Directed instruction. Teachers should transmit a predefined set of information to students through teacher-organized activities. This view is based on objectivism, a belief system grounded primarily in behaviorist learning theory and the information processing branch of the cognitive learning theories. Next is the constructivist-based instruction. Teachers should build inquiry, discovery, and experiential learning into their instruction so that learners can generate their own knowledge through experiences while teachers serve as facilitators. This view is based on constructivism, which evolved from other branches of thinking in cognitive learning theory. There are meaningful roles for both directed instruction and constructivist learning strategies and the technology applications associated with them. Both can help teachers and students meet the many and varied requirements of learning in today's knowledge society. Origins of these instructional perspectives. Objectivists. Knowledge has a separate, real existence of its own outside the human mind. Learning happens when the knowledge is transmitted to people who store it in their minds in ways that they can be retrieved later. Constructivists. Humans construct all knowledge in their minds by participating in experiences. Learning occurs when someone constructs both mechanisms for learning and the person's own unique version of the knowledge informed by background, experiences, and aptitudes. Learning theory foundations of directed integration models. Behaviorist theories. These theories, among the earliest explanations for how people learn new things, are based primarily on the work of Boros Frederick Skinner. Before Skinner, theories of learning were dominated by classical conditioning concepts proposed by Russian physiologist Ivan Pavlov, who proposed that behavior is largely controlled by involuntary physical responses to outside stimuli. By contrast, Skinner's operant conditioning theory asserted that people can have voluntary mental control over their responses. Scientific work had not advanced sufficiently at that time to observe brain activity. Therefore, he concentrated on cause and effect relationships that could be established by observation. He found that human behavior could be shaped by contingencies of reinforcement or situations in which reinforcement for a learner is contingent on a desired response. He identified three kinds of situations that can shape behavior. Positive reinforcement. A situation is set up so that an increase in a desired behavior will result from a stimulus. Next is a negative reinforcement. A situation is set up so that an increase in a desired behavior will result from avoiding or removing a stimulus. And lastly, the punishment. A situation is set up so that a decrease in a desired behavior will result from undesirable consequences. Implications of behaviorist theories for technology integration. Most original drill and practice software was based on Skinner's reinforcement principles, such as when students knew they would receive praise or an entertaining graphic if they give correct answers. Much tutorial software is based on the idea of programmed instruction. Information processing theories. Educators found Skinner's stimulus-response view of learned behavior insufficient to guide all types of learning. So during the 1950s and the 1960s, the first cognitive as opposed to behavioral learning theorists began to hypothesize about processes inside the brain that allow human beings to learn and remember but could not be observed directly. The work of the information processing theorists is based on a model of memory and storage originally proposed by Atkinson and Schiffer in 1968. The brain contains certain structures that process information much like a computer. This model of the mind as computer hypothesizes that the human brain has three kinds of memory or stored. Sensory registers. This is the part of the memory that receives all the information a person senses. Short-term memory. Also known as working memory. This is a part of memory where new information is held temporarily until it is either lost or placed into long-term memory. Long-term memory. This is a part of memory that has unlimited capacity and can hold information indefinitely. Implications of information processing theories for education. Although subsequent studies have indicated that learning could be more complicated than this model of memory would explain, information processing views have become the basis for many common classroom practices. Implications of information processing theories for technology integration. Computer programs provide ideal environments for the highly structured queuing, attention-getting, visualization, and practice features that information processing theorists found so essential to learning and remembering. Cognitive behaviorist theory. Robert Gagne was a renowned educational psychologist who translated principles from behaviorist and information processing theories into practical instructional strategies that teachers could employ with directed instruction. He is best known for three of his contributions in this area: events of instruction, types of learning, and learning hierarchies. Gagne used the information processing model of internal processes to derive a set of guidelines that teachers could follow to arrange optimal conditions of learning. Implications of cognitive behaviorist theory for technology integration. Computer-based methods such as drills and tutorials were deemed useful because they could consistently provide the ideal events and conditions of learning. Systems approaches, instructional design models. Seattle 1990 proposed that instructional systems developed scientifically precede the 21st century but pointed out that modern instructional design models and methods have their roots in the collaborative work of Robert Gagne and Leslie Briggs. When Gagne and Briggs combined their two areas of expertise, the result was a set of step-by-step processes known as a systems approach to instructional design or systematic instructional design, which came into common use in 1970s and 1980s. Implications of system approaches for technology integration. Most directed models for using technology resources are based on systems approaches, that is, teachers set objectives for a lesson and then develop a sequence of activities. Objectivist theory foundations for directed methods. So this figure shows how these four theories contribute to directed technology integration. Strategies based on mastery learning approaches, or sequences of objectives that once met define mastery of a subject. A considerable body of research indicates that directed methods work well to foster this kind of approach.
Learning theory foundations of constructivist integration models. Social activism theory. John Dewey is considered a philosopher and an educational writer. In many ways, he can be thought as the grandfather of constructivism. Curricula should arise from students' interests. Dewey deplored standardization. He felt curriculum should be flexible and tailored to the needs of each student. A pedocentric strategy where the children are central rather than scoliocentric where the institution is central. Curricular topics should be integrated rather than isolated from each other. Dewey felt that isolating topics from one another prevented learners from grasping the whole of knowledge and caused skills and facts to be viewed as unrelated bits of information. Education is growth rather than an end in itself. Dewey did not share the common view of that time that education is preparation for work. He found that this view served to separate society into social classes and promote elitism. Rather, he looked at education as a way of helping individuals understand their culture and develop their relationship to society and their unique roles in it. Education occurs through its connection with life rather than through participation in curriculum. Dewey felt that social consciousness was the ultimate aim of all education. To be useful, all learning had to be in the context of social experience. However, he found that school skills such as reading and mathematics were becoming ends in themselves, disconnected from any meaningful social context. Learning should be hands-on and experience-based rather than abstract. Dewey objected to commonly used teaching methods characterized by teacher-to-student communication channels and prioritized memorization and recall. He believed that meaningful learning resulted from students working cooperatively on tasks that were directly related to their interests. Implications of social activism for technology integration. Dewey would likely have approved of technologies such as use of the web to help students communicate with each other and learn more about their society. Social cognitive theory. The work of Albert Bandura challenged some of the major premises of conditioning theories that were most popular at that time. He said that contrary to the behavioral theories of reinforcement, students learned a great deal through observation, which he called vicarious learning, rather than through their actions, which he also called inactive learning. Bandura found that one of the most powerful ways students learned was by observing the behaviors modeled by those around them. Self-efficacy beliefs can be shaped by teachers and others and can affect whether students even try to learn as well as how long they persist at learning tasks. Implications of social cognitive theory for technology integration. Video examples can provide many examples of models that teachers would not otherwise have at their disposal. In addition, studies have shown that self-modeling videos in which students watch examples of their own successful performance can increase their self-efficacy in the area. Scaffolding theories. Lev Semenovich Vygotsky was a Russian philosopher and educational psychologist whose ideas had more influence on the development of educational theory and practice in America than in his own country. Vygotsky felt that cognitive development was directly related to and based on social development. What children learn and how they think are derived directly from the culture around them. Children learn by scaffolding, or building what they need to know on what they know with the help of adults. Vygotsky referred to the difference between these two levels of cognitive functioning, adult expert and child or novice, as the zone of proximal development or ZPD. Implications of scaffolding theories for technology integration. Many constructivist models of technology use the concepts of scaffolding and developing each individual's potential. Many of the more visual tools, from Logo, a programming language designed to let young students solve design problems with an on-screen cursor or small robot called a turtle, to virtual reality, are used under the assumption that they can help bring the students up from their level of understanding to a higher level by showing graphic examples and by giving them real-life experiences relevant to their individual needs. Child development theory. French biologist Jean Piaget explored early stages of development in children and the role of environment in these stages. Piaget's examination of how thinking and reasoning abilities develop in the human mind began with observation of his own children and developed into a career that spanned some 60 years. He referred to himself as a genetic epistemologist, or a scientist who studies how knowledge begins and develops in individuals. Piaget believed that all children go through 4 stages of cognitive development, whereas the ages at which they experience these stages vary somewhat. He felt that each child developed higher reasoning abilities in the sum sequence. Sensory motor stage from birth to about 2 years. Pre-operational stage from about age 2 to about age 7. Concrete operational stage from about age 7 to about age 11. Formal operation stage from about age 12 to about age 15. Implications of Child Development Theory for Technology Integration. Piaget's pupil mathematician Seymour Papert of the Massachusetts Institute of Technology used Piaget's theories as the basis of his work with Logo. This environment provided the vital link that Papert felt would allow children to move with easily from the concrete operations or earlier stages of development to more abstract operations. Discovery learning. Educational theorist Jerome Bruner was interested in children's stages of cognitive development and believed that children go through 3 stages of intellectual development: an active stage, iconic stage, symbolic stage. Implications of discovery learning for technology integration. Many of the more radical constructivist uses of technology employ a discovery learning approach suggested by Bruner. For example, rather than telling students how logic circuits work, a teacher might allow students to use a simulation that lets them discover the rules themselves. Multiple intelligence theory. Of all the learning and developmental theories embraced by constructivists, Howard Gardner is the only one that attempted to define the role of intelligence in learning. Gardner's multiple intelligences theory is based on Guilford's pioneering work on the structure of intellect. Implications of multiple intelligence theory for technology integration. Gardner's theory matches well with the trend toward using technology to support group work. When educators assign students to groups to develop a multimedia products, they can assign roles to students based on their type of intelligence. For example, a group of students conducting a research project might distribute responsibilities, with those with high interpersonal intelligence could be the project coordinators. Those with high logical mathematical ability can be responsible for data analysis and charts, and those with spatial ability can be responsible for presentation aesthetics. Social constructivist theory foundations for technology integration methods. These theories were designed to address a problem that John Seeley Brown called inert knowledge, a term introduced by Whitehead in 1929 to mean skills that students learned but did not know how to transfer later to problems that required their application.
In today's rapidly evolving educational landscape, the integration of technology has become increasingly essential to enhance teaching and learning experience. To effectively incorporate technology into education, educators often turn to theoretical frameworks such as directed and constructivist theories. Today, I'm going to discuss to you the innovative ways technology is transforming education through the lens of directed and constructivist. Directed instruction focuses on teaching specific skills systematically, while constructivist emphasizes building knowledge through unique problem-solving experiences. Instruction and assessment in directed and constructivist theories. Here are the instructional needs in directed models. First is the accountability that all students must meet required education standard to be considered educated. 2 is individualization. This helps meet individual needs of students working at many levels. Number 3 is equality assurance, that the quality of the instruction must be consistently high across teachers and schools in various locations. And number 4 is the convergent thinking, that all students must have the same skills. The first instructional needs in constructivist models is the higher level skills, that all students must be able to think critically and creatively and solve problems. Cooperative group skills, this helps students learn to work with others to solve problems. Increased relevancy, that students must have active, visual, authentic learning experience that relate to their own lives. Number 4 is divergent thinking, that students must think on their own and solve novel problems as they occur. Also, here are the methods of instruction in directed models. First is stress individualized work, have specific skill-based instructional goals and objectives that are the same for all students. Transmit a set body of skills and or knowledge to students. Have students learn prerequisite skills required for each new skill. Provide sequences of carefully structured presentations and activities to help students understand the process, remember or encode and store and transfer retrieve information and skills. Use teacher-directed methods and materials such as lectures and skill worksheets. In constructivist models, the methods of instruction are stress group-based, cooperative work, have a global goal such as problem-solving and critical thinking that sometimes differ for each student. Have students generate their own knowledge through experiences anchored in real-life situations. Have students learn lower-order skills in the context of higher-order problems that require them, providing learning through problem-oriented activities, for example, what-if situations, and visual formats in mental models, rich complex learning environments and exploration. Use materials to promote student-driven exploration and problem-solving. Next is the assessment strategies in directed and constructivist model. And directed assessments are example multiple choice, short answer that emphasize knowledge, recall with specific expected responses. That student products are example essay are graded with checklists or rubrics. In constructivist models, assessment are example group products such as web pages, multimedia projects that emphasizes application of knowledge with varying contents or portfolios. Student products are graded with self-report instruments and rubrics. Let's proceed in technology integration strategies based on directed, constructivist, and both models. In directed models, integration to address skill deficits, to enhance skill fluency, to facilitate self-paced learning, and support concept learning and review. In constructivist models, integration to encourage creative problem solving, to facilitate building mental models and knowledge transfer, to promote group cooperation, and to accommodate diverse intelligences. For both models, integration to increase motivation for learning, to maximize limited resources, to overcome logistical barriers to learning, and to promote digital citizenship skills. Let's proceed to another lesson, which is Turnaround Technology Integration Pedagogy and Planning, or TTIPP model. And this section introduces a model to help teachers plan to integrate technology into their teaching. Each step in the model's three phases helps ensure that technology use will be meaningful and successful in meeting learning needs through the process of building a revitalized curriculum that engage all students. In phase 1, which is the analysis of learning and teaching assets and needs, it has three steps, which is number 1, it's about identify teaching and learning challenges. In step 2, it's about evaluate available technological resources. And in step 3, it's about identify potential technology solutions for addressing challenges. In phase 2, which is the design of the integration framework, and its step 4 is about set learning objectives and assessments. Step 5 is plan integration strategies and assess their advantages. And in step 6 is about prepare the instructional environment and implement the lesson, ensuring resources are organized for effective teaching and technology is functioning correctly. In the last phase, which is the post-instruction analysis and revisions, and it's step 7, it's about evaluate lesson outcomes and student feedback. And in step 8, it's about adjust materials, logistics, and strategies based on results. And in step 9, it's about share lessons and outcomes with other teachers to extend impact and promote collaboration. And that's the end of our report. Thank you for listening.